100 years ago, a population was 3.3 billion. Well, you could then say that the population at time t is equal to the initial population, which is right now 3.5 billion, times e to the RT power. We don't know what the growth rate is. We'll need to solve for r, among other things here. But this describes in t years what the population is. At time 0, that's now. Right now is time 0. So t is equal to 0 right now. So 100 years ago, that would be p of negative 100. So 3.5 times e to the r times negative 100. 100 years ago, t was equal to negative 100. And we know that then the population was 3.3 billion. This is our equation in billions. Our equation counts how many billions of people. Okay, so if we divide both sides of this equation by 3.5, we get that e to the negative 100r is equal to, let's see, 3.3 divided by 3.5. Let's just leave it like that. In fact, we can write it as 33/35 if we want. Now, writing this in logarithmic form, or taking the natural log of both sides, it amounts to the same thing. Either taking the natural log of both sides of the equation, or just writing this exponential equation in logarithmic form. Either way, we end up with negative 100r equals the natural log of 33 divided by 35. This lets us solve for r. Dividing both sides by negative 100, we get that r is equal to negative the natural log of 33 divided by 35, all divided by 100. This is quite important to have solved for r here. We need this value of r to answer any other questions about this equation, this population, including what will the population be 100 years from now, 100 years in the future. I'm going to leave it in this form. It's more compact than if you write it out as a big long decimal. And it's best not to round off a number like that. So let's now answer the question, what will the population be 100 years in the future? 100 years hence. Save my r value down there. So what is p of 100? It's 3.5 times e to the r times 100. But now we know what r is, remember. It's not an unknown. It's now this. We'll use it when we need to calculate it. Well, I guess we need to calculate it now. So this is 3.5 times e to the negative natural log of 33 divided by 35, all divided by 100. And then this is times 100. That's r times t. And notice that the hundreds cancel out. And so we're left with 3.5 times e to the negative natural log of that power. Now, if I was to move this exponent up, using that nice property of logs that we have, this becomes e to the natural log of 33/35 to the minus 1 power. And when you raise a fraction to a negative 1 power, that takes the reciprocal of the fraction. So this is the natural log of 35 divided by 33. So let's calculate this and see what we get. The natural, okay, so first of all we take 35 divided by 33. Then take the natural log of that. Well, actually, e to the natural log of that is just that. That's the whole point of doing it like this. So it's 3.5 times 35 33rds. Or you could calculate it, you'd find the same thing. So finally, we get 35 divided by 33, and then multiply that times 3.5, and we get 3.7. Well, 1, 2, 1, 2. That's how many billions of people. So rounding it off to the nearest tenth of a billion, this is about 3.7 billion. The population 100 years in the future.